Hi, welcome to my channel, JaberTime. Here's a triple integration. Use spherical coordinates to evaluate the triple integration of x to the second plus y to the second over the region E, which lies between the two spheres, x squared plus y squared plus z squared equals 4, that means radius 2, and x squared plus y squared plus z squared equals 9, with radius 3. Now, since we have here x squared plus y squared, that's not going to be a volume. Okay, let's get started. Here's the problem again. Now, we need to find the bounds for the triple integration. And here's the first one. I mentioned that the radius rho here is 2 and the radius here rho, which is 3. So rho goes from 2 to 3. Now theta for a sphere goes all the way around from 0 to 2 pi, and phi goes all the way from 0 on the top all the way down to pi. So that's something we have to know before we get started. Now, what about dv? Well, for spherical coordinates, dv is rho square sine phi d rho d theta d phi. Inside we have x squared plus y squared. We need to translate that into spherical language. So what's x squared plus y squared? Rho squared sine squared phi cosine squared theta. That's for x squared. And for y squared is going to be rho squared sine squared phi sine squared theta. So they look similar. The difference is this is sine instead of cosine for theta. Now notice that they both terms, they have rho square sine square phi, rho square sine square phi. We could take this out as a common factor. What we have left from this term is cosine square, and from this term sine square. And what we know about cosine square plus sine square of the same angle is 1. So that's going to be simplified to rho square sine square phi. So what is x squared plus y squared? That's going to be this right here to summarize it. And let's go back to the triple integration now. We have the bounds, the limits. We have the inside part also. And now the triple integration. Here's the bounds. And here's x squared plus y squared. And here's dv. Now the way I do things, why do I write my notes ahead of time? Because I don't want to record a video that takes 45 minutes if I could do it in half the time. And that helps me a lot to save some time from you guys watching the videos. I write my notes and I kind of like color things if I can to distinguish parts and to make them outstanding. This is what I mean. Notice that theta shows up here. It doesn't show anywhere else. So I'm gonna take it by itself. Rho square and rho square right here will be rho 4. That goes with d rho. And phi with sine phi goes together. I do have sine square here and one more sine of phi. So that's going to be sine cube. Now, I could jump in to the answers, but in case if you need help with sine cube, triple integration, or integrating sine cube, those integrations, they need some practice from calculus 2, but I have it for you. So here we go. We'll come back to this problem. Sine cube. In case if we call it x for the convenience, we could break it down to sine square and sine, where sine square is 1 minus cosine square. Doing the distributive property here, or applying it, we have sine times 1 and sine times cosine square. So we'll take this right here, and we're going to use u substitution in this box. We're going to call cosine x u, du dx, differentiating u with respect to x will give me minus sine x. If I cross multiply, I get du by itself minus sine x dx. So the minus sine x dx, the minus sine x dx will be du. So I could take the minus inside next to the sine x. That's one option. There's a lot of different ways, of course, doing that. But I don't want to confuse you. That's just an option. I do have the minus, I do have the sine x and the dx. Here's the minus, here's sine x, here's dx. Let's call that, put them inside and call it du. So the outside part becomes plus because we took the minus inside. So that's u squared, that's du. We left this by itself because we're not touching it for now. The integration of sine is minus cosine x. Integration of u squared will be u cubed over 3. We do have for both integration a constant of integration, c. Let's take u back to cosine x. So that's cosine cube x plus 3. Now we have the integration of sine cube x equals cosine cube x over 3 minus cosine x. Of course, we're not going to use the c part here. It's just like, since we do have bounds. So here's our problem. The first part we said it's a minus cosine phi because we're using phi, not x. And we have cosine cube, that's the u cube over 3. We're going to go from 0 to pi. This will be integration of 1 will be theta from 0 to 2 pi, and this will be integration of rho q square, rho to the 4th with respect to rho. That's going to be rho to the 5th over 5 from 2 to 3. That's a simple substitution, and as I said, I don't want to take your time. That's what we have. Cosine pi, after you plug in instead of phi, which is 1, negative 1, that's a negative 1, and cosine 0 is 1. 1 cube over 3, that's this one here, when you plug in 0. When you plug in pi all the way to the left, that's cosine pi, which is negative 1. Negative 1 third, or negative 1 to the 3rd will be negative 1. It's going to stay negative. And plug in 2 pi, plug in 0, you just get 2 pi. Plug in 3 to the 5th over 5, that's 243 over 5. Plug in 2 to the 5th, that's 32 over 5, and simplifying. Now, I could do this as I'm recording, but you could just follow along. You could pause the video and double check your numbers. This is what I have. The first part is 4/3, the second part is 2 pi, and the third part is 211 over 5. Doing the math, I have 1688 pi over 15. And that should do it. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.